Video analytics is a type of software that analyzes video to detect and determine temporal and spatial events. Now, what does that mean? Well, the purpose of video analytics is to alert us when certain conditions in the scene are true. It can be used to alert us when something has moved in the scene, when something has been added or removed from the scene, when an imaginary line has been crossed in the scene, etc. The most basic analytic was introduced 30 years ago, motion detection. Alert me if something moves in the scene. Today, the capabilities of analytic software have evolved to offer directional motion detection, intrusion detection, object removal detection, people counting, crowd detection, and many more. There's a common misunderstanding regarding the purpose for which video analytics is being used. It is indeed a new technology whose role is automation. But unlike automation in manufacturing or the service industry, it's normally not used to replace human work, but rather it's used as a tool to enhance human efforts. Here's the situation we find ourselves in today. The world has deployed so many security cameras, it's just not possible for human operators to monitor all video streams all the time. There are simply too many. So let's do this. Let's use software, specifically video analytics, to pre-filter which video streams human operators should be looking at. Since software can be scaled and deployed to monitor all video streams, we can use it to help determine which cameras our human operators should be monitoring. It's really just a tool to help direct our attention to the situations that need it. Video analytics software is quite resource-intensive, requiring decent computing power. Analytics can be run in many cameras or on the server. When should we set up analytics to be run on the camera versus the server? Well, here's the general rule of thumb. The server already has a lot of work to do, and we want to offload as much processing as possible to free up its resources. Test the camera's analytic accuracy. If it's satisfactory, have the cameras run the video analytics. But if the camera's analytics are unreliable, or you have cameras that don't support onboard analytics, then we'd configure the server to run the analyses, understanding that it will require a lot of the server, and we should prepare with a properly spec'd server. More and more camera manufacturers are offering advanced analytic capabilities in their cameras. But you need to be careful because not all models will offer analytics. Once a camera that does support analytics has been added to Security Center, we will receive that camera's analytic events in a metadata stream accompanying the camera's video stream, and write them to our database, and make them available to trigger actions or for historical reporting. Instead of running the analysis in the camera, we can also run the analytics on the server. In most cases, we would choose one or the other, either edge-based analytics or server-based analytics. Now, when it comes to server-based analytics, here's what's available within Security Center. Motion detection, the grandfather of all analytics. We can define a zone of interest, and the software will fire an event if changes exceed a certain threshold. Privacy protection. We define a zone of interest, and the software will pixelate moving objects within that zone. This is used to respect privacy rights. The pixelation is an overlay that can be applied or removed by administrators. Camera integrity monitoring. We capture a reference image from each camera and check at a regular interval if the camera is still pointed where it should be. It'll fire a special event if the camera is suddenly out of focus or pointed in the wrong direction. And visual tracking, which is a visual overlay allowing you to link cameras to their immediate neighbors. Clicking the visual tracking overlay on one camera would take you to the adjacent camera's video stream, with the purpose being to help an operator more easily follow an intruder within a building. No special server role is required for these four analytics. They're built into the feature set of an archiver. If you've got cameras in your system, you've already got an archiver. But there's more. By adding the optional Kiwi Vision server role, we can take advantage of many more analytic modules. These Kiwi Vision analytic modules are used primarily for intrusion detection, object detection, and people counting, but there are many customizations and variations available. For example, stopped vehicle detection is really just a variation of basic object detection. Tailgating detection is really a combination of object detection and people counting. And direction control is really just directional motion detection. Let's take a look at the Kiwi Vision server-based analytic architecture. The minimum required server roles would be an archiver, a media router, a Kiwi Vision analyzer, and a Kiwi Vision manager. Every Security Center system used for video already has a media router and one or more archivers. They're needed just to manage cameras and video streams in our system. But the Kiwi Vision Manager and analyzers really are specific to the needs of server-based analytics. Every Security Center system used to manage video will have a directory role, a media router role, and an archiver role. There may be more server roles running, but these three would be the minimum. Depending on the scale of the system, these server roles might all be running on one server, or they might be distributed across multiple servers. Cameras connect to the archiver, and that's the basic architecture for video management. Now, if we want to add Kiwi Vision server-based analytics, we'll need to add some additional server roles. A Kiwi Vision Manager, and a Kiwi Vision Analyzer, or perhaps multiple analyzers depending on the workload we expect. The Kiwi Vision Manager acts as a dispatcher, assigning analytic workloads to the analyzers using a round-robin strategy to spread the workload across multiple analyzers. Keep in mind that video analytics is very resource-intensive, so resource management is something to keep an eye on. And in the Config Tool application, we can select the Kiwi Vision Manager and see what workloads it has assigned to which analyzers. And we can even see the resource utilization on those analyzers: CPU, GPU, and RAM utilization. If we find that the manager's round-robin strategy hasn't balanced the workload equally across the analyzers, we can manually balance the workload. Select an analytic job and drag it to a different server. So hopefully I've given you a good base of understanding for video analytics in general and the Kiwi Vision server-based architecture.